Hi friends, in last video we have learned Euclid's division lemma and we have also find HCF and LCM using Euclid's division lemma. In this video we will learn to find HCF and LCM by prime factorization method. Now let's start. So first of all, the question number 2 says find HCF and LCM. Also, we have to verify LHS into RHS is equal to A into B. And now what are A and B? A and B are the numbers which we are given whose HCF and LCM we are finding. And in textbook they have written here is equal to product of two numbers. Okay, so we have to verify that LHS into RHS is product of two numbers. So the first sum, that is 26 and 91. So first of all, as I have taught you earlier, we have to find the prime factorization of both the numbers. So first of all, 26, and as we know that 26 is 13 multiplied by 2. So I will not write it like this, 26, 2, 13, 13, 1. It is not necessary to write if you know the factors. I know the factors of 26, that is 2 multiplied by 13. Now the factors of 91. Okay, so what are the factors of 91? 13 sevens are. So 13 sevens are 91. So I have written here 7 multiplied by 13. In this way, I have factorized them. Now HCF. Now friends, what is the full form of HCF? HCF, that means highest common factor. Highest common factor. So what we have to find? We have to find the factor which is common in both. We can say that 13 is a common factor in both. So I can write HCF as 13. Now I have to find LCM. Now friends, LCM that means least common multiple. That means least common multiple. Now least common multiple that means the table. Okay, so if you want to find the multiple of 13, right? If you want to find the multiple of 13, then you can write it as 13, 13 2s are 26, 13 3s are 39, 13 4s are 52, and so on. So there are numerous such multiples of 13. But we have to find the least common multiple. Least common multiple, that means the smallest multiple which is common in both the numbers. Okay, now it is very lengthy process to write the multiples of 26 and 91 and then to find the smallest common multiple. Instead of that, what we will do? We will write the common factor once. Again, what I have told you, we have to write the common factor once. Yeah, that means we will write 13 only once. Now I will write the remaining factors. So which are the remaining factors? 2 and 7. So I will write here 2 and 7. So we have 13 multiplied by 14. So 13 into 14, that will be your LCM. Now you can do the multiplication here. 13 4s are 52. Here we have written 2 and carry over 5. 13 1s are 13 and 13 plus 5 it is 18. So I can say that the least common multiple of LCM of these two numbers is 182. Now I will verify LHS into RHS, and that is equal to product of two numbers. The product of two numbers, that means A multiplied by B, where I can consider A as 26 and consider B as 91. So first of all, I will find here LHS. LHS, that is, sorry, I have written wrong here. Here it is not LHS and RHS, it is LCM and HCF. Sorry friends, here we have to prove HCF into LCM is equal to product of two numbers. So I will write here HCF multiplied by LCM. That is our left hand side. So LHS we are given is HCF into LCM. Now what is HCF? We have obtained HCF 13 and we have obtained LCM 182. So I will write here 13 multiplied by 182. Again, if you know the table of 13, you can do the multiplication directly. 13 2s are 26, carry over 2. 13 8s are 104, 104 plus 2, that is 106, and carry over 10. 13 1s are 13, 13 plus 10, that is 23. So we have LHS, that is HCF into LCM, is 2, 3, 6, 6. Now I will find RHS, that is right hand side, which is the product of two numbers. Product, that means multiplication. Product means multiplication. We have to find the product of two numbers. Product, that means multiplication of two numbers. The two numbers we have are 26 and 91. So I will write here 26 multiplied by 91. Again, what we can do? We can split the numbers so that we can do that multiplication easily. I can split it as 13 multiplied by 2 multiplied by 91, right? I have split 26 into 13 into 2. No matter, you will do this multiplication at the back of your notebook, but I will teach you how to do mathematics easily, okay? So I have split 27 into 13 into 2. So I will keep 13 as it is. Now 2 into 1 it is 2, 2 9s are 18. We have the same number here. So the multiplication will also same. 2, 3, 6, 6. So here friends we get left hand side and right hand side same. I will give it equation 1, I will give it equation 2. So I can say that from 1 and 2, LHS is equal to RHS, which means that the highest common factor and least common multiple, the product of these two will be equal to A into B, right? So in this way, we can simplify the term, that means to find the HCF and LCM of two numbers 26 and 91. Okay, question number 3. The question number 3, that is find HCF and LCM of the given numbers. The first number we are given is 12, 15 and 21, right? So we are given three numbers that are 12, 15 and 21. Now first of all I will factorize 12. Now you all know what are the factors of 12. It is 4 multiplied by 3. And 4 is not a prime number, right? We know the factors of 12, 4 into 3, but 4 is not a prime number, it is a composite number. So we can further factorize 4 as 2 multiplied by 2. So the prime factors of 12 can be written as 2 into 2 into 3. Now the prime factors of 15. So 15, the prime factors of 15 are 5 3s are 15. So the prime factors of 15 will be 5 and 3. Now the 21, the prime factors of 21 will be 7 into 3. So in this way, first of all, we have to find the prime factors of the given numbers. Now what I will do? I will find the HCF. Again, HCF, that is highest common factor. The factor which is common in all the three terms. In earlier sum, we are given two numbers, so we have to find highest common factor in two numbers. Here we are given three numbers, so we have to find the common factor in all the three numbers, right? In these three numbers, the common factor is 3. So I will write that HCF, that is highest common factor, is 3. Now LCM. Again, whatever the idea of finding HCF and LCM should be applied here. The HCF, that means the common factor, should be written once, right? Now we have to write the remaining factors. The remaining factors are 2, 2, 5 and 7. I will write here 2, 2, 5 and 7. 2, 2, 5 and 7. Now I will simplify it, right? 2 2s are 4 and 4 5s are 20, right? 5 into 2 into 2, that will be 20. And 7 into 3, that is 21. So 2 1s are 2, 2 2s are 4 and followed with 0. So our LCM will be 420. So in this way, we can find HCF and LCM of 3 numbers. Now we will learn question number 4. We are given HCF of 306 and 657 is equal to 9, and we have to find the LCM of 306 and 657. So here we will apply the formula which we have done earlier. The formula is HCF into LCM is equal to A into B. Here A and B are the product of two numbers. So now instead of HCF, I can write 9. And LCM that I have to find. So I will write LCM as it is. Instead of A, I will write 306, and instead of B, I will write 657. Now we need LCM, so we will take this 9 on right hand side. And as the 9 will move on right hand side, here it is in multiplication, and if it goes on right side, it will be in division. So I can write that, therefore, LCM is equal to 306 into 657 upon 9. So in this way, I can find the LCM. Now 9 3s are 27 and the remainder 3, 36. 9 4s are 36. Okay, so that it is 34 multiplied by 657. Now I have to multiply it with 657 multiplied by 34. Now I will multiply it as 7 4s are 28, carry over 2, 5 4s are 20 plus 2, 22 carry over 2, 4 6 are 24 plus 2, 26. Now here I will write 0, 3 7s are 21 carry over 2, 3 5s are 15 plus 2, 17 carry over 1, and 3 6 are 18 plus 1 it is 19. It will be 8, 3, 3 carry over 1, 2 and 1, so it will be 2 2 3 8. So our answer will be 2 2 3 8, and hence I can say that the LCM of 306 and 657 will be 2 2 3 8. Got it? Now we will do question number 5. Okay. Now we have to check if 6 raised to n ends with 0 or not. So we have to check if 6 raised to n ends with digit 0 or not. Now we have to take it for any natural number n. Now as we can say that n is a natural number, n may have the values 1, 2, 3, 4, any value it may have. Now I will substitute this value in place of n. So if first I will substitute 1, so it is 6, and as you can see it does not end with 0. Now I will substitute 2, so 6 raised to 2, that is 6 multiplied by 6, and it is 36. 6 raised to 2, that means 6 multiplied by 6, and that is 36. It also ends with 6. Now the third one, 6 raised to 3, that is 6 into 6 into 6, and that is 216. And so on. If you move up to infinite, it will never end with 0. It will always end with 6. So I can say that from above, we can say that 6 raised to n cannot end with digit 0. So in this way we can solve it. So if you are given any number, what you have to do? You have to simply substitute the values of n. And if it is, you can say yes. If it does not occur, you can say no. Now the sixth one, that is explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 1 are composite numbers. And friends, as I have told you earlier, what are composite numbers? Composite numbers, that means numbers which have more than 2 factors. It must have more than 2 factors, okay? Now the first, that is 7 into 11 into 13 and plus 13. Here we have two terms. The first term, that is 7 into 11 into 13. And the second term we have is 13. Now, as we have learned the factors of AB plus A, we can take A common. The remaining factor is B plus 1. I will apply the same method here. I can take 13 common from both. So the remaining terms are 7 into 11, and here I have taken 13 factor common, so the remaining will be 1. So now I have taken 13 here, so remaining factor will be 1. As I have told you, 1 is the factor of all the numbers. So it is 13 bracket 7 into 11 plus 1. That can be written as 13 into 11, 7s are 77, and 77 plus 1, that will be 78. Okay. Now, we can say that it's a composite number because we have said that composite number, that is the number which have more than 2 factors. Here I can write 13 into 78 into 1, as I have told you that 1 is factor of all. So here we have more than 2 more than 2 factors, and hence I can say that it is a composite number. So I will write it here. The number has more than 2 factors. Hence, it is a composite number. Okay? Now the second one, which is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Okay. Now here also we have 2 terms, and I will take 5 common from both. The remaining terms I will have are 7, 6, 4, 3, 2, 1. Again, I have taken 5 common, so the factor left will be 1. Now, here I have 5. Here 7 into 6, 42. 4 into 3 into 2, that is 4 3s are 12, 12 2s are 24, and plus 1. I will multiply it separately. 42 into 24. 4 2s are 8, 4 4s are 16. 2 2s are 4, 4 2s are 8. It will be 8, 0, 10. It will be 1, 0, 0, 8 plus 1. That is 5 into 1, 0, 0, 9. Got it? So here I can write multiply by 1 as 1 is the factor of all the numbers, and hence I can write that here the number has more than 2 factors. The number has more than 2 factors, hence it is a composite number. So it is very much easier. You do not need to multiply these 3 numbers, then add 13 in it, and then factorize. It is a tedious job to do. So we can do it easily as taking 13 common from both the terms. And we have proved that it has more than 2 factors, and hence it is a composite number. Now we will do question number 7. Question number 7 is a problem sum, and this type of questions are surely asked in the examination. I am reading the question that there is a circular path around a sports field. I will draw a circular path. Okay, I will draw a circular path. There is a circular path around the sports field. Sonia takes 18 minutes to complete a round. Sonia, it takes 18 minutes to complete the one round. And Ravi takes 12 minutes to complete a round. Ravi takes 12 minutes to complete a round. Suppose they both start at the same point. For example, they start from here, that is point A. Right? Ravi and Sonia, they both move on this circular path. We have to find after how many minutes will they meet again. We have to find after how many minutes they will meet again. Okay. Now just forget the HCF and LCM of this. We just have to think that Sonia takes 18 minutes to complete a round. Okay. Then how much time she will take to complete two rounds? First round 18 minutes, another round another 18 minutes. That is, for first round Sonia takes 18 minutes and Ravi takes 12 minutes. In second round, when the second round is completed, Sonia has taken 36 minutes while Ravi has completed it in 24 minutes. For the third round, Sonia has taken 54. 18 2s are 36, 18 3s are 54, and here it is 36. Okay? Now you can see that they both have a common multiple 36, and hence we can say that they will meet after 36 minutes. This is just our logic. But what we have done here, we have just find the least common multiple. So I will do it same here. Sonia has taken 18 minutes and Ravi has taken 12 minutes. So what I will do first, I will find the HCF, I will find the LCM of it. Okay? So what I will do now, I will find the LCM of 18 and 12. The factors of 18 can be written as 18, that is 9 2s are. So it is 2 into 3 into 3. And 12, that is 4 3s are. That is 2 multiplied by 2 multiplied by 3. Now we have to find the LCM. Now what I have told you earlier, to find LCM, we have to find the common we have to write the common factors once. So which are the common factors? 2, 3. This is the HCF. I have to write the HCF once. Then I will write the remaining factors, that is 2 into 3. Got it? So we will have 3 into 3, 9, 9 2s are 18 and 18 2s are 36. So I can write that they will meet after 36 minutes, and that is your answer. So here we have completed exercise 1.2. In next video, we will learn about irrational numbers, which is the third part of our chapter number 1, and that is the third and final part. And after completion of this, we will complete our first chapter. Okay? Goodbye.